Okay, we are going to start with writing out some basic limit laws. So this is going to give us some shortcuts that we can apply. So for all these basic limit laws, what we need is if limit as x approaches c of f of x and limit as x approaches c of g of x exist, then we get the following laws. So the first one is the sum law. And what it says is if limit as x approaches c of f of x and limit as x approaches c of g of x exist, then the limit as x approaches c of the sum of those two functions, f of x plus g of x, that exists. And furthermore, the limit as x approaches c of f of x, plus g of x equals the sum of the two limits. Limit as x approaches c of f of x plus limit as x approaches c of g of x. All right, so second, we have the constant multiple law. So we'll say for any k, we get the limit as x approaches c of k times f of x exists. And furthermore, with this, you're able to say the limit as x approaches c of k times f of x. You're able to pull the k out front of the limit, and that will be k times the limit as x approaches c of f of x. So with all of these laws, we got a couple more to write down. We have the product law. So this is step 3. If the initial two limits exist, then the limit of the product exists. So if f of x, g of x exists, and we get the limit as x approaches c of f of x times g of x ends up equaling the product of the two limits. So it equals the limit as x approaches c of f of x multiplied by the limit as x approaches c of g of x. So we got two more. Fourth one's the quotient law. And in the quotient law, this basically says if the limit as x approaches c of g of x is not equal to 0, then we get the limit as x approaches c of f of x over g of x exists. And we get the limit as x approaches c of f of x over g of x equals limit as x approaches c of f of x over limit x approaches c of g of x. Again, limit as x approaches c of g of x cannot equal 0 because that will cause division by 0, which would make bad things happen. But as long as that limit exists and is not 0, then the limit of the division is the same as the limit of the top divided by the limit of the bottom. All right, last one has a couple things here. We get P and Q are integers. So this is power and roots. Sorry, let me write that out. So this last one's power and roots. We get P and Q are integers with Q not equal to 0. Then limit as x approaches c of f of x to the p over q. Again, if q was 0, then this p over q, we'd have division by 0 in the power, which would cause problems. Then that limit exists, and we get the following thing. Limit as x approaches c of f of x to the p over q is equal to, you can take the limit of the function and then raise that to the p over q power afterwards. So now we get some other stuff about, this is still kind of under 5, but it's got its own little headings here. So we're going to assume limit as x approaches c of the function f of x is positive. Because all this stuff up here worked just as long as these were whole numbers and q was not 0. But now to get these other statements, we need f of x to be a positive number. If q is even, and limit as x approaches c, f of x is not equal to 0, then if p over q is less than 0 for n a positive integer, we get the following relationships. Limit as x approaches c of f of x to the nth power equals limit as x approaches c of f of x to the n. So basically, you're able to pull the limit inside the power. So if you want to know the limit of something raised to a power, as long as all this stuff is set up correctly, then you can pull the limit inside. And we also get the limit as x approaches c of the nth root of f of x equals n times the square root of the limit, or sorry, the nth root of the limit as x approaches c of f of x. So for the second limit, we need to assume that limit as x approaches c limit as x approaches c of f of x is greater than 0 if n is even. Because you can't take even root of a negative number, so we need to make sure that we're only talking about even roots. So like if we're talking about the square root of -7, that goes imaginary, that's not good, or fourth root of a -8. So for this rule to apply all the time, we need to make sure that we're only talking about nth roots of things that make sense and don't have weird stuff like going to the imaginary system. Okay, so that is some setup. I'm going to try to write up in the module below this. I'm going to try to write this up a little bit cleaner. But then we're able to, if we look at some of the results from earlier, if I have limit as x approaches c of x to the p over q. Well, by the work we did, we were able to see that this should be the same thing from, what is it, statement 5? Let's see, where's the one with p over q? Yeah, this statement here, we're going to use this first. That equals limit as x approaches c of x to the p over q power. And from that theorem we did last class, or a couple classes ago, when you want limit as x approaches c of just x, that is c. So this equals c to the p over q. And we can put that together to get us a nice little equation. Limit as x approaches c of x to the p over q will equal c to the p over q. So I will try to write up these equations nicely underneath this video in the thing before we go on into some extra examples.